It's our final day in this series, our 3-a-day CXC multiple choice questions, and we are working the May 2011 paper. If you are a regular here, then you already know what's up, all right? We're going to be doing 3 questions, and these are the final 3 questions for this paper. Praise the Lord. All right, so we are going to get right into things, and if you are here, especially when this is premiering, you can just send the link to a friend so that we all can benefit from this. Let me know how has the entire series been for you. All right, we are going to now go to question 58. And we looked at rotation yesterday, so we're going to look at a bit of that right now. The triangle, LMN, is rotated in a clockwise direction. So we already know it's supposed to be going that way. Through an angle of 90 degrees, what is its image? All right, here we go. And yesterday I showed you a little property, basically. We said that if we should rotate something 90 degrees, then the distance between, all right, hold on. Well, the angle between, all right, so let's take, for example, here, LM. And if we are rotating that line 90 degrees, then it's going to end up where I have placed the red line, because there should be a 90-degree measurement between those 2 lines. All right, so we're looking at what the shape should look like. All right, so that image should end up about there. Let me see if I can make it a little more accurate. If it doesn't work this time, we're still going. All right, let's look at that line LN, and we're trying to create L prime, N prime. All right, which means the distance between this line here and the new line I'm going to draw for the image should be 90 degrees. All right, so 90 degrees, which means that other line is going to end up here, which means when I'm done, my triangle should look something like this, with L prime being there. Oops, oops, oops. Let me take this part back off. Right, so let's draw this line a little longer. Yeah, all right, and then the one I drew before, it's gonna look a little like this. All right, so that would be where my L prime would basically be, M prime and N prime. Which of these diagrams kind of look like that? And I definitely say kind of, because that's horrible drawing. All right, so we're gonna have, of course, you must have figured it out by now. The answer would have been B. Mark you, both of these may not have the same center, because one is L, one point is L, and one point is L prime, according to the options we're given in our answer. But the point is, I'm just showing you how the image would be positioned. All right, so B is correct. Number 59, it says a boy stands 12 meters from the foot of the building, and you make a connection with the diagram while you're reading. Good, so we see the 12 meters away from the building, and observes the angle of elevation of the top of the building. So from his head top, preferably his eyesight, all right, there's an angle of elevation 40 degrees, all right? We can see that. Now it says, what is the height of the building? So we need to know the height of the building, which means by looking at this, we need to know the distance that I just marked off, which includes right here. And I'm just gonna give you 2 seconds to pick up what would be the measurement for that part of the measurement up to that height, from the foot of the building up to that height. That would have been 1.6 meters, just like it is right here. So now all I need to do is see if I can figure out how much meters this part is, and add them together. All right, so it's going to be 1.6 meters plus something else. Already I start ruling out A as a potential answer. All right, so here we go. Let me remove that 1.6 so I can write something else there. So we're looking at this triangle, the one with the 40 degrees here. All right, and we are trying to find this side, which would mean that it is, let's call it X, which would mean that it is the opposite side in this triangle. All right, because it's opposite to the angle. And do we know any of the other two sides? We don't know this one, nope. But we do secretly know the other. So if this distance here that he's standing away from the building is 12, then right here is also 12. So let's go with 12 meters. Now we can go ahead and use the appropriate ratio. So are we going to be using sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent? All right, which side do we have? The opposite. Cosine does not carry opposite. We already know that's out. And which side do we want? That's our opposite. Which side do we have that is going to be our adjacent? The ratio that has both of those in it would have been tangent. All right. So let's go. Tan, whatever the angle is opposite over adjacent. So tan 40 degrees is equal to opposite over adjacent 12. And you don't try to work out what tan 40 degrees is, of course. Just to be sure, we're going to finish up our answer. But of course, you can already tell that the answers with sine and cosine in them are incorrect. All right, and we want to find x, so we get rid of 12. Multiply both sides by 12. So now we have x, which is this distance, x. The other piece of the height of the building is equal to 12 tan 40 degrees. And we did say our total height of the building would be this 1.6 here plus x. And that makes this. Final question for the entire week, for the year. Let's go. It says a ladder 5 meters long is leaning against a wall. And immediately you start sketching. Wall. Ladder. I would draw a ladder, but that ain't gonna work out. All right, a ladder is 5 meters long, okay? Leaning against a vertical wall. The foot of the ladder is 3 meters away from the wall on horizontal ground. All right, let's get some different ink up in here. So this distance, which is where I really should use the broken lines, is gonna be 3 meters. Now, some of you, after being so used to questions where you use the Pythagoras theorem, because Pythagoras theorem deals with when you have two sides of a right angle triangle and you want to find the length of the other side. All right. So if you are used to this, you already know that the answer is 4, because the numbers 3, 4, 5 are what we call a Pythagorean triplet. Like everybody knows it. So like after today, you're supposed to know it. All right. So if the hypotenuse is 5 and one of the sides are 4, the other side are 3. If the hypotenuse is 5 and one of the other sides is 3, the other one will be 4. They go hand in hand. All right. But the 5 definitely must be for the longer side for this to work. Anyway, we're gonna work it out. Here we go. We know the Pythagoras theorem tells us that, all right, we're just gonna call this X, because the question says how far up the wall does the ladder reach? So that's what we are focusing on. All right, so even though I know the answer, we are gonna, and many of you may, gonna revise how to work it out. So here we go. We know that the length of the hypotenuse is equal to the sum of the squares of the other two sides. So x squared plus 3 squared. And you may have seen this formula in the form a squared equals b squared plus c squared, or c squared equals a squared plus b squared. It doesn't matter, right? I deliberately didn't write those because you need to understand that is the hypotenuse squared equal sum of the squares of the other two sides. That's all. But I didn't want to name Z, P, Q, we don't care. All right. We're trying to find x clearly. 5 squared is 25 equals x squared plus 3 squared is 9. Trying to find x, so let's get rid of this 9 here. Minus 9 minus 9. So now we have 25 minus 9 equals x squared, which means 16 is equal to x squared, which means right away we can tell by square rooting that x is going to be 4. All right, and so 4 meters is our final answer. And it's officially goodbye from DG Makes Math Easy. We're intentional about making math dimensional. I will see you next year.